Today, it's point motors. So today I thought I'd go for a fireside chat look and discuss point motors. Of course you don't need point motors, there are always alternatives, and if you go to an exhibition then naturally you'll find lots of layouts there, and some of them don't use point motors at all. They clearly have points, but what people use is they do it manually. They'll either reach across the layout and change the point, or have a simple pull rod system of going underneath the baseboard, and on a small exhibition layout that might be 4 or 6 foot long by 2 foot wide, it's an easy alternative. Of course you don't have to do it manually, you can do it electrically, and if you've got a biggish layout then that tends to be the way we go. You can put points above the baseboard, which doesn't necessarily look good, though you can disguise them, or you can put them underneath the baseboard. Point motors basically come down to 2 ways of operation. There's the solenoid point motor, which makes a sort of a thuddy noise as it changes the point over, or there's the slow action point motor, which makes a quiet whirring sound that lasts about 5 seconds. There's obviously good things about one and advantages on the other one too. So what's the advantages of the solenoid point motor? Well, they're about 1/4 of the price of a slow action point motor. Apart from the economy, is there any other real advantage? Well, they're smaller, they're about 1/3 of the size, but they are more difficult really to put together and install, and you end up buying various components to get it to work properly. Whereas if you buy the slow action point motor, you just get left with one big hunk and you sort of thread a wire through it and install it, and it's pretty much good to go. But there must be more to it than just that, surely. Well, I think as we embark on our model railway hobby, money is always a limiting factor. So you naturally lean towards solenoid point motors. And if you're a DC layout, then as you make your isolating switches and you build your layout, let's say going into your loco shed, then you operate your point motors and they kind of go clunk. Then the noise is actually exacerbated by the drumming effect of the baseboard, so it's not just a quiet doink, it's more of a loudish sort of snap. Whereas again the solenoid, the slow action point motors just tend to go whir. Moving on to DCC layouts away from DC, then there's kind of 2 modelling philosophies with DCC. There are guys that want to drive the train as they normally would, which of course you don't do with a DC layout. You don't drive the train, you drive the track. So somewhere between 1 volt and 12 volts, your locomotive will go faster or slower, but all you're doing is changing the voltage in the track. Of course with DCC that isn't the case. You do actually drive the locomotive or the chip that's in the locomotive, and then if you just turn the speed back to 0, the locomotive doesn't stop, it tends to slow down and then stop, more like the real thing. So you drive the train and not the track. So coming on from there, when you move from just straight DC to DCC and sound, you have these enormously expensive sound files that are programmed into locomotives, and you might get a class 47 and you can hear the things start up, and you hear the brakes come on or go off, and the horn sounds and the engines run up. You get an engine failure and a multitude of sounds. You get bells ringing on DMUs, you get the chuffing with the steam engines, and the lovely sound from HST units thundering through a station. But when you've invested that kind of money in sound locomotives, and then you set the route for the loco to leave the station, and if you've embarked on these solenoid point motors, then all you get is doink, 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 doink as the route is set and the engine leaves the station. Perhaps not such a good idea. So what's the best for you? Well, the only person that can really decide that is obviously you. You know what your needs are and you know what your budget is. And of course you know where you are in your modelling career. I've sort of drawn a line in the sand with Chadwick there, and the whole layout is fitted with both Pico and Seep solenoid point motors, and there must be, I don't know, 20-25 points on there. And I can't really justify putting in slow action point motors into that loco shed. However, I could look at just changing the main line and when building the new layout, whether to put slow action point motors into the new area. So looking at slow action point motors, what are our choices? Well, you can actually get a little line side shed. I think this one's from Hornby, and you can connect that one up, and that will change the points for you, mounted above the baseboard. And on Chadwick TMD, sadly, I have 1 point mounted above the baseboard, disguised cunningly as a signal box, which perhaps kind of works, perhaps it doesn't, but I had no real choice, as underneath that point, or right next to it, there's a great big timber. But there we go. So originally all the rest of the points on Chadwick TMD I'd kind of set up using these Pico, I think they're PL10Es, but please don't take my word for that. Ordinary kind of solenoid point motor. Of course there's always more money involved than you think, and to go with this point motor you then need an adapter base plate, I think it is, to go underneath, and that's this little plate here, so that needs to then screw onto the underside of the baseboard. If you're using electro frog points, then naturally you will need an accessory switch to go on the top, so that when the point is thrown, if I use that one there, so when the point is thrown you can change the polarity of the frog. Or perhaps, if you really want to invest, you can buy yourself twin micro switches, and then perhaps you can change a signal at the same time, and a frog. So you can build upon these basic Pico switches, but they still go bonk when you change them. I found them to be not that reliable, because what was happening was this accessory switch would break down, it would come off, and it wasn't too good. So that's when I moved over to seat points. And this is the basis of the seat point, much the same as the Hornby one but smaller, mounts straight onto the baseboard, and then you can see you solder your wires onto there. This happens to be, I think, made by Gauge Master. It's a Seep PM1. And you don't need kind of any other bits that you do on the Hornby ones, which kind of makes things a little more simple. I had problems with the Hornby ones. Sometimes they would energise and you could hear the doink, but it wouldn't quite throw the point. It would get stuck halfway. And if that ever happens to you, what you could try doing is releasing the point, just unscrewing the 4 screws slightly so it will wobble, and then try it. And that helped me get around that problem. You also need to invest in a CDU, a capacitor discharge unit, and these capacitors store more power, so when you throw these solenoid points, you have more than adequate power to get them to change over. You might find that if you just change a pair of points, that the power source that you're using just doesn't have enough oomph to make them to snap over with the right amount of power to overcome the small springs that are in the points. So naturally you need a CDU, making the wiring more complicated, and it's another little investment. And I think these are around about sort of £15-20 a go. Again, you can get them from Gauge Master. So that kind of sums up where we are with these solenoid points. But as I said earlier, they're about a quarter of the price of the slow action points. The slow action points are made by, the big names are Cobalt and Tortoise. And for better or worse, for the new layout, I have laid my colours with Tortoise. And I recently bought a pack of 12. I hope you're sitting down. 12 of these little beauties with a small guide to help you fit them. Was pennies under £200. £200 is a great deal of money. It's the price of a sound loco and 20 quid change. So is that really a great deal of money? Well, clearly it is, but when you compare it to other things that you buy, and let's say things tend to double in value every 10 years. So you buy that Class 47 with sound and it might cost you 150 quid as opposed to £200 for these. In 10 years time, you might want to get rid of that Class 47 because the new one has better lights, the doors open, it has automatic unlocking, it does better sound, better modelling, it's been completely revamped and it's a better model. But you've still got these and there's nothing wrong with them. These tend not to go out of date. The solenoids don't last forever. Invariably they get worn and some of them burn out, depends on the method that you use to change them. So I have laid at the altar of Tortoise. And the only real reason I've chosen Tortoise over Cobalt is some of my friends have got Cobalt, some of my friends have got Tortoise. And the Tortoise ones are a little bit quieter. They don't quite whir as loudly as the Cobalts. So there we go. The advantage of the Cobalts, some of them, I think you can get a certain range that have the DCC chip already in them, whereas these don't. If you want to run them from a DCC system, then you'll need another component, you'll need an accessory decoder. But there we are. That's what I've done. That's what Chadwick, the new Chadwick, is going to have fitted. It's these. So I bought 12. Hopefully in the next video I shall show you how to fit these and be honest about the advantages or the disadvantages and how easy or not so easy it is to fit them. I read the book. It seems quite straightforward really. You know, there's 6 contacts here. The outside 2 are for the power, and you just power it up and it changes, and you reverse the polarity and it goes back the other way. And there's the little whirring noise if you can hear it. And then you've got 6 contacts. There's 3 for the frog, or 3 on the other side for the frog, or for an LED, or for a light, or for a signal. So the jury's still out. I haven't tried them. I have committed some money to them, so hopefully I haven't made a bad choice. But we live and learn. Let's see how we get on. Anyway, thank you very much for watching. As usual, there should be a video here and a video here for you to watch if you're watching this on YouTube and not on a mobile phone. And I would ask you to subscribe and perhaps give us a thumbs up. And I'll see you in the next video. Thank you very much. Bye-bye.